Hi, FINM2412 students. This is Noah here, one of the tutors for the course. And today I will be taking you through an explanation of the assignment and question 1 in particular. And what you'll see is after I've uploaded this, the two remaining tutors will upload similar videos walking you through question 2 and 3 as well. So I'm going to quickly start with giving you some basic information on the assignment. So due on the 24th of May, about just over a month from now, and it's a group assignment worth 20%. And our expectation from you is that you submit an Excel spreadsheet walking through how you've answered each question with all your worksheets clearly labeled. So we'd like a sheet with question 1, question 2, question 3, or broken down even more if possible, as well as a written report where you walk through all your logic behind answering each question. So lectures 6 to 8 are what is the material that's being covered in this assignment. And the most important part, your final mark is going to equal your peer assessment factor multiplied by the sum of your best 2 answers. So it gives a really good explanation here, but if you perform very well in question 1 and question 2, but don't perform as well in question 3, only question 2 and question 1 will be interpreted for your grade. Amazing. So now we've got that out of the way, let's quickly walk through question 1. So part A of question 1 is asking us about unconventional cash flows. So as we see there, for unconventional cash flows, there will often be multiple IRRs. Under those circumstances, we cannot use IRR for evaluation purposes. So part 1 is construct a hypothetical unconventional cash flow that yields 2 possible IRRs. Present your cash flows in a table and plot its NPV profile. So we're going to be doing this in Excel, and I've provided you an example just here. So this is what the NPV profile is, what we're looking for the NPV profile to look like. And as we discussed in class, hint, hint, how do we interpret an IRR from an NPV graph? And you guys should be able to remember that. And from that, you can tell that this graph accurately represents 2 IRRs. If I quickly delete this and walk us through how we went, I went about this. So I chose 5 years of cash flows. Please don't do the same values as I will notice. However, I chose randomly these values, and from that was able to plot NPVs according to various discount rates. So if we just walk through one of the formulas, we started out with the cash flow at time 0, which does not need to be discounted back, so we don't need to do anything with it. And then from year 1 to 5, the cash flows there in purple, we're discounting them back to year 0 using our discount rate of 0% there in red. And so I've done that for all discount rates from 0% to 48%. And from that, we can go about producing an NPV profile. So I might quickly reword this to NPV profile. And as I was mentioning before, this graph is representing 2 IRRs, and you should be able to understand why and write about that in your report. But this is what we're looking for you to produce and replicate in your assignment. Excellent. So from that, we can move to part 2, which is asking us to do the same thing, but this time we want the unconventional cash flows to yield 3 possible IRRs. So I'm not going to show you an example of that, but very similar process to the 2 possible IRRs. However, we just want to show 3 on a graph in this instance. And the only other part of this question is assess which of your 2 hypothetical projects you would rather invest in. And so that will stem from what your 2 possible IRR NPV profile and 3 possible IRR NPV profile produced, and you'll be able to draw a conclusion from that. Finally, part 3 is more so a logic explanation question as opposed to anything in Excel, but briefly explain how you would construct an unconventional cash flow in order to have K possible IRRs where K is greater than 1. So where K is greater than 1, that is exactly what we've done in part 1 and part 2. We have K is equal to 2 and K is equal to 3 in those instances. So it's really talking about the logic as to and how you went about constructing an unconventional cash flow like those in part 1 and part 2. Finally, comment on the likelihood of such cash flows occurring in real life when K is large. So that's going to be a really interesting part to comment on in your report, where you can pull maybe an empirical study or discuss examples that you've experienced in your own life as to whether or not having unconventional cash flows is really a possibility in the real world. So really noting when K is large here. Amazing. So that is part A of question 1 answered. And now we'll move on to part B, which is more so looking at enterprise value. Amazing. So we can see here that our enterprise value is equal to our market value of equity plus debt minus cash. However, importantly, we can see here that net debt is debt minus cash. So we can substitute this value out, make it simpler by this term is now net debt. So now we have enterprise value, market value of equity, and net debt as our 3 values in this formula. And we're going to need to manipulate this to isolate one of the variables, and you'll see that soon. I might jump ahead from that as it walks us through how we calculate enterprise value, because the best way here is to think about it by working backwards. So the first question would like us to answer, what is the current value of Simpkins shares? So that's just asking, what is the share price for one of their shares? And so we valued shares in this course thus far using the dividend discount model. However, I'm not sure whether or not you guys have seen this formula, but this is also a great way of going about it. And I'll bring it up here. So the price of a share is equal to its market value of equity divided by the shares outstanding. So the number of shares available. Excellent. So hint, hint, this value, the denominator, may already be given unto us. So the key here is going to be calculating our market value of equity, whereby we will then be able to answer part 1, which will be this value. So from that, we can see the company has 6 million shares outstanding. So we are provided with our denominator. So all we need to do for part 1 is find out what the market value of equity is. And to do that, we will go back up to this formula. And we can see this value here. So we're going to need to isolate this variable to get the answer. So to do that, we are going to need, as we mentioned before, this is net debt. And fortunately, if we work our way down here, we're provided our net debt value. So this is going to be equal to 1 million. And finally, we need to calculate our enterprise value. So this, once again, the market value is what we need. We know our answer over here on the right. And so we need to calculate enterprise value to be able to find our market value. Amazing. So in order to calculate enterprise value, we do it as this paragraph suggests. And I'll encourage you guys to read this in your own time. But all it's saying is that the enterprise value is the present value of the firm's free cash flows. So we're going to be doing exactly what we've done throughout the tutorials in this class. And we're going to be discounting all free cash flows back to present value to get our enterprise value. Excellent. So we're provided our cash flows for the next 5 years, which is great. And the important part here is assuming the free cash flows after 2025 will grow at 3% for the next 3 years. So 2026, 2027, 2028 will be growing at 3%. And then finally, after that period, it will be growing at 2% thereafter. So we have a growing perpetuity into the future after that period. And you will remember that in our tutorials, we broke down how we went about segmenting these aspects. And so I encourage you to go back and look at your notes, as you'll be doing the exact same thing here. However, I encourage you to do it in Excel, and that is the expectation, and it's a lot easier. Excellent. So this discounting back using our discount rate of 10% of all those future free cash flows is going to give us our enterprise value. From that, we will have our answer here. We already know our answer here. And so we will be able to determine our market value of equity. And from that, we will have this answer. And we also already know our shares outstanding. So from those two values, we will be able to determine our price, which is what is expected for part one. And there's only one more part of question one, and that is looking at 3 mutually exclusive projects that could impact future free cash flow. And importantly, no new debt is raised to fund these activities. So you don't need to worry about any change in net debt. It will still be the same as the question before. So the cost of capital will still be the same. So the discounting back to present value is going to be the exact same in this question as it was in the question above. However, all we're doing here is discounting back these values each individually to see the enterprise value impact and adding that on to the question above to see how it impacts the stock valuation and then the resulting stock price, assuming the same 16 million shares outstanding for each scenario. So I encourage you, when you're modeling this out in your Excel spreadsheet, to have 3 separate sections for project A, project B, project C. Keep them all separate, and you'll be able to see for each one how they are impacting the stock valuation and the resulting stock price compared to the question above. And from that, you'll be able to conclude which project, if any, should the company pursue. So do we recommend that they pursue one of these projects, or are none of them beneficial to the company? So that is going to be a conclusion to draw based on the values you produce in your report. Excellent. So that is question 1 answered. Us tutors will have 2 assignment consultation sessions around the middle of May. So I encourage you to come to those if you have any questions. Other than that, I encourage you to get on top of this early and answer as much as you can. And other than that, all the best with it. And thank you.